Hi, my name is Yoram Eshri. I'm the CEO of Nostromo Energy, and I'd like to thank you for accepting us to the second phase of this important program. In this short presentation, I'd like to share with you Nostromo's vision of turning buildings into large-scale energy storage assets and propose a testbed for the GSA and DOE to evaluate this technology, which can both significantly decarbonize federal buildings, but also serve as a large virtual power plant to help also decarbonize the power grid. Now, energy for space cooling accounts for about half of a building's peak electricity demand. That's a tremendous opportunity for storing energy, whether during off-peak hours when power is generally cheap and clean, or from surplus renewables for use later when it's unavailable, or when power is both expensive and carbon intensive. Now, Nostromo system charges energy by creating ice using its tremendous latent heat storage capacity, and discharges it to power commercial cooling systems, which consumes a vast amount of energy. It has three components. The first is the patented ice brick, which stores the energy in form of encapsulated ice. Each unit is about 14 feet long and stores about 10 ton-hours of cold energy, which is equivalent to about 10 kilowatt hours on average. The system will typically consist of more than 100 bricks, so this means megawatt-hour scale systems. The second component is the Envoy on-site integrated management system. It controls the coolant flow and contains all the communications and metering and program controllers and so on. The system connects to the building chillers with a separate glycol loop through a heat exchanger, which can be disconnected if necessary. And the third component is a Cirrus. That's a software cloud-based remote management platform. It controls and optimizes the system's operation, provides analytics, including your carbon emission reduction, and also the grid interface to enable interactive load management and aggregation of multiple systems to form a large-scale virtual power plant. Now, on the innovation side, we believe our technology has overcome the main barriers for implementing large-scale energy storage in buildings, and particularly when we're thinking about the existing building stocks or the retrofit need. Now, these benefits or advantages include four important components. First, the minimal footprint or the real estate. Thanks to the compact and modular design, this is key to implementation, particularly in commercial buildings, where real estate is very expensive. And also, these buildings are big consumers of about half of the energy on the grid. Now, second important is the encapsulated ice design compared to the traditional ice and coil enables both better performance, including faster and more stable discharge and a higher round trip efficiency, but also more durable, as we'll explain immediately. And the fourth is the systems is constantly monitored for both optimization and preventive care. The only other commercially available storage option for existing buildings is lithium-ion batteries. It is not a very practical option because of the fire risk, in addition to recycling challenges, the shorter lifetime, supply chain constraints, and last but not least, about 70% of the Nostromo installed cost of the Nostromo system are spent in the US. Now, in terms of maturity, the Nostromo system is market ready. It is, in fact, already installed in 2 customer sites in Israel, where it's completed over 560 daily cycles, which is equivalent of 2 years in service. So we give it a TRL of between an 8 and a 9. One system is installed at a building of Israel's largest HVAC integrator, and the other as a global medical device manufacturer. The systems were evaluated, supported, and followed by several government branches, such as the Ministry of Energy and its Ministry of Environmental Protection, and also the Innovation Authority, and recently also the Tel Aviv Stock Exchange as we become a public company. We also received building permits for our first 2 systems in California, one of them at the Beverly Hills, which we would suggest as the testbed for this RFI. There are strong market forces for adopting this type of technology, such as the increasing energy costs, the desire of building owners to lower carbon footprint, freeing capacity to charge more electric vehicles, and operating benefits like taking a backup of your cooling system, and for the grid, benefits like reducing loads to prevent local blackouts, save infrastructure costs, and also help integrate more renewables. Now, the operations and maintenance has been a main focus area for us in developing the system. By design, encapsulated ice can be more durable because the failure of one capsule does not impact any of the other capsules, unlike traditional ice and coil, where coolant leakage could potentially disable an entire tank. And having thousands of capsules in a system further mitigates the risk of performance loss. The only maintenance of the ice brick is a simple periodic fluid check. All other components are off the shelf. They're widely used in the HVAC industry, like the chiller, pump sensors, and valves, and they all have standard service and maintenance contracts. The system includes more than 50 meters and sensors, both for performance monitoring and optimization, but also for preventive care and early failure alerts. And customers can monitor the system in real time from their mobile phone. Now, talking about performance, the system really demonstrated state-of-the-art performance metrics for energy storage system. In terms of durability, as we mentioned, has undergone accelerated stress testing that simulated 20 to 25 years in service. That included 6,600 thermal cycles and more than 300,000 mechanical cycles, all with less than 1% degradation. From a cost and ROI perspective, the system has a similar upfront capital cost as existing lithium-ion behind-the-meter batteries, but has significant cost benefits such as the double lifetime and deeper discharge depth. On the impact side, a small 1.5 megawatt-hour system will have a net annual CO2 reduction of 20 to almost 100 tons, depending on the energy charging source. This means about 8 million tons of CO2 saved annually if installed on the 140,000 buildings in the US, which are chiller-cooled and owner-occupied, including government buildings. Now, about the test bed setting, for this, we propose a system that is in the process of installation at the Hilton Beverly Hills. Climate there is mild to hot year-round. It's an indoor installation. It received all necessary permits, and we expect it to go online before the summer. This prime location and building, which was built in the 50s, it can really demonstrate nicely how even an older building can be retrofitted to become a safe and sustainable energy storage asset. In terms of the value of participation, which we highly appreciate, there are several important benefits for us. One is government engagement will increase awareness of energy storage in buildings in general, which is critical to decarbonizing buildings and the entire grid. Now, these two agencies are leaders in evaluating and adopting new technologies for buildings, so your leadership can accelerate market deployment, and which is very important for us. The benefits to customers are great, but not always enough to provide the expected financial returns. So incentives like the ITC and removal of barriers to different market programs is key, and hopefully this program will help accelerate that as well. So we hope we could work together on turning many federal buildings into energy assets and virtual power plants, and we look forward to partnering with you and making our joint handprint bigger than our footprint. So thank you very much, and we look forward to that.